Alright, today we are going to solve many examples as much as possible on uniformly accelerated motion so we can practice those equations we just derived in the previous video. So the first question says a boy, or rather a body which is uniformly retarded. Yes, retardation now simply means is also acceleration but with negative acceleration. So when the acceleration is positive, just say the body is accelerating, meaning the speed is increasing, but when the speed is decreasing, it's retarding or decelerating. So that's it. Comes to a rest. So I think as we do, just take down the value of everything that we're working with. So you said that it comes to rest in 10 seconds. So that's time. So the time is 10 seconds. That's one. After traveling, okay, we missed something. Please remember, I said that we always take this word down, rest. So you see that this body comes to rest. Coming to rest means the final velocity now has to be 0. So v is 0 because of it comes to rest. After traveling a distance s is 20 meter, we have to calculate its initial velocity. So we are looking for u, that's the initial velocity. All right, so which formula can we use? Remember, we have about 4 formulas from the previous video. So if you've not, I want you to go and watch that video. It's going to help you to understand what's going on here. So every time you want to solve, you need to identify which formula suits your arrangement most. So the formula that we can use here is that s is equal to u plus v, average velocity times time, because we have all these parameters given. The only thing we don't have is the initial value of velocity, which is u, so we can just find u. So let's let's substitute rather. S is 20, so that's 20 is equal to u, which we are looking for, plus 0, because final velocity is 0 over 2, and that will be times time, and time is 10 seconds. So this is 20 is equal to u plus 0 is just u over 2, then times time. We can go ahead and cancel out because 2 here is 1. 2 into 10 is 5. So if we multiply, we're going to have, let me just continue my solving here, that 20 now is equal to 5 times u is just 5u. So we just divide both sides by 5. So 5 is going to cancel out there. So that u is 20 divided by 5 is 4 meter per second, which is the unit of velocity. So the initial velocity is simply 4 meter per second, and that's the answer. So let's see another question. This question says a body moving with uniform acceleration as acceleration a, all right, so that's just the acceleration, so I'll put it in the brackets. Acceleration a has 2.5, 15 and 20, 16. Now anytime acceleration is represented with points, it means we are dealing with the velocity time graph, as you can see there. So I've covered a video extensively, at least, that guides us on how to solve questions relating velocity time graph. So I want you to watch that video. It's going to prove to be very helpful, so you understand what is going on here. The video link will also be in the description. Just click on more, you're going to see the link to that video. So I wouldn't say much since I've already done a video on this, but you know that anytime we have a velocity time graph, the acceleration is the gradient or the slope of the velocity time graph. And what's slope? So acceleration is the slope, and you know that slope is simply y2 minus y1 all over s2 minus x1, which is the acceleration. So clearly we're going to put values for the first coordinates. You see that this is our y1, this is our x1, all right, because that's the way coordinates are represented, and this is y2 and x2. So let's put the value. See that y2 is 60 minus y1 is 15 all over x2 is 20, y1 is 5. So if we solve this, very simple, get the acceleration, because I also calculate a, which is the acceleration. 60 minus 15 is 45 over 20 minus 5 is 15. So we can use 5. 5 into 15 is 3. 5 into 45 is 9. Then 3 can go again. 3 into itself is 1. 3 into 9 is 3. So the acceleration is 3 meter per second squared. Remember, we can also denote this as 3 meter per second squared. So whichever way you like. So that's the answer. Very simple. All right, let's go to the next question. It says an orange fruit. Now, I advise for you to, since you solved 2 examples already, pause the video and see if you can solve this on your own, and then you play again. An orange fruit drops to the ground from the top of a tree, from the top of each tree, which is 5 meters high. So remember, we always write down the parameters. So the height in this case is 5 meters. Now, how long? We're looking for the time. That's what we're looking for. It takes to reach the ground. Well, one thing you must observe is that if an orange fruit is on the tree, remember that when it's still on that tree, it's not moving yet, right? So the initial velocity will be 0 since it was at rest until the time it dropped. So initial velocity is 0. And then anytime you have a question that has to do with height, because this tree is going to be, a level above the ground, so we're going to be dealing with the vertical component of motion, vertical component of the motion. So acceleration now will be acceleration due to gravity g. So even if it's not given to you in the question, acceleration due to gravity is always negative 9.8 meter per second squared. This is to be exact. I've already explained how or why is negative. All right. I've explained why it's negative in the previous video, but just for easy calculations, we always like to approximate our acceleration due to gravity to 10, since 9.82 is very close to 10 if you approximate to a nearest whole number. So in this case, I'm going to use 10. All right, so our g is negative. Now, should we use negative or positive? You see that the fruit, how will I just draw this? So don't laugh at my drawing. This is the fruit, all right? So this fruit is dropping down. You know that acceleration due to gravity is a downward force also, and the fruit is going in the same direction. Remember, anytime what is falling, the body is moving the same direction with acceleration due to gravity. We just use positive. So we just have 10 meters per second. Now, these are the parameters we have. Okay, so you know that if you remember, we said that anytime the distance, anytime we have a height and the initial velocity is 0, we can use the formula h is equal to half gt squared. Basically, the full version of this formula is ut plus half gt squared. But since u is 0, so u times 0 times t is just 0. So this will cancel out. We have this formula. So let's use that to find the time. The height is 5. Substituting now. Half times g is 10, t, that's what I'm looking for basically. So let's just we can use 2 and cancel out t. 2 here, 2 is 5, so we have this will imply that 5 is equal to t squared times 5 is 5t squared. So just divide both sides by 5. All right, so that's 1. That'll give you 1. So again, we have that t squared is equal to 1. Well, to find t, we just find the square root of both sides, so that t is equal to the square root of 1. Square root of 1 times 1 is 1, so the square root of 1 is also 1, and time is in seconds. So you just took the fruit 1 second to reach the ground, and that's the answer. Okay, let's go to the next question. A ball thrown vertically upwards from the ground. Again, pause this video and try to attempt it on your own. A ball thrown vertically upwards from the ground level hits the ground after 4 seconds. Calculate the maximum height it reached during its journey. Well, we have the horizontal floor there, because this ball was thrown from the ground. Now, there's something you need to pay attention to very importantly. If this ball, let's say we have a ball at this point, if it was thrown vertically upwards, you know that it's going to be going against gravity, right? So anytime it's going against gravity, the speed of the ball is going to be reducing, decreasing until a point where the speed becomes 0, and then it changes direction and falls back to the ground. So that's what we have. So now from this, the height, this will be the, no, I think I should go the other direction. So this height from the ground to that point, that highest point where the ball will get to, is what we call the maximum height. So that's what we're asked to find, right? So this is the h max, which is maximum height. So once I need you to know is that, remember, this ball was thrown up, so it's going to have initial velocity, which is the velocity it was thrown by, but then it keeps decreasing because of it's going against gravity, because acceleration due to gravity is downward. So this ball is going upward, it's going against gravity, so the speed will be decreasing until where the speed becomes zero, right? So you see that the speed becomes 0. So the final velocity at the maximum height is 0. I hope you understand, because it started with an initial velocity. It keeps decreasing until at the maximum height the velocity there becomes 0. Then it begins to fall back to the ground. So now I want you to note something. When this ball begins to fall back immediately, then you know that momentarily when the final velocity is 0, the ball is no longer moving, it's just changing direction. Now as it begins to change direction and begins to fall back to the ground, again initial velocity there will now be 0. So at this point, initial velocity is not 0, please. It was thrown with a speed, so we don't know the speed, let's just call it s, we don't care. Then when it falls back to the ground, the final velocity will be equal to that initial velocity, because it started from this level, is back to this level. So this is a symmetrical kind of motion, because the time it takes for this ball to move from, let's call this point A, call this point the highest point B, and call this point C. The time it takes for the ball to move from A to B is also equal to the time to take to move from B to C. All right, so if the total time is 4 seconds, you want to agree with me that the time it takes to move from A to B will be 2 seconds. That means A to B. And also the time it takes to move from B to C will also be 2 seconds. If you add 2 plus 2, you get 4. So let's work with BC. So we're going to use the equation that height is equal to half gt squared. I'm using half gt squared because initial velocity from BC now is what? 0. It's 0. So I can use this formula. Now, since we're looking for the height, h now will be the maximum height. The reason why I'm even using initial velocity as 0 is because of I'm looking for h maximum. So that's when the initial velocity is 0. I hope you just get everything clearly. So it's equal to half times acceleration due to gravity now will be 10. Since the ball is falling back to the ground, I'm using this part of the graph. So it's going to be positive 10 times. The time is 2, please, not 4. All right, 2 squared basically is still 4. All right, so 2 here is 1, 2 here is what? 1. So it's important to use 2. I think I need to pray. If you use 4, you have 4 times 4, which will be 16, which is wrong. You use 2 times 2 because that's the time from the maximum height back to the ground, not 4 now. So the maximum height, h maximum, I'll just finish the solving there, is just 10 times 2, which is 20. So 20 meters. I had a little struggle in trying to explain this because most students are always confused in this type of question. So one thing you must know is that if the ball was thrown up, the time it takes to get to the maximum height is equal to the time it takes to move from the maximum height back to the ground. Alright, so if its total time is 4 seconds, note that it took 2 seconds to get to the maximum height, 2 seconds to fall back to the ground. And at the maximum height, the final velocity of the first phase is 0, and the initial velocity of the second phase is 0. It's kind of wonderful if you try to understand all these things. So that's the final answer there. So now this is a question for you. I would like for you to solve this question. I won't solve it in this video. Now this is a velocity time graph question, so read the question. I've already done a comprehensive, at least comprehensive I would say, that teaching on velocity time graph, how to understand, interpret and use it in solving. So you watch the video, the link will be in the description below. Watch the video and then try to solve this after watching the video. Drop your answers in the comments, and just in case you also want a solution to this, drop your answer in the comments so I will see that and get back to you. So I believe I've done a good work today to at least make the concept of uniformly accelerated motion to be a bit easier to you. So practice builds our muscles around this thing, so keep practicing, and it becomes very easy by and by.